So often we're going to have trig equations that we need to solve that are going to have more than one trig equation, or a certain identity is going to appear in the equation, and so we need to use our identities to solve them. So here's some strategies. When you look at your equation, can you write your equation with only one trig function? Now we've done some of these before. We've done some where there was a cos x and a sine squared, and we replaced the sine squared with 1 minus cos squared, and then our equation only had cos in it. We had some equations, maybe it has cosecant and sine, and you could change the cosecant to 1 over sine, and then you have a trig function that only has a trig equation with only one trig function in it, and then you can solve it. So ones that you often use are sine squared plus cos squared. Sometimes you can also use your double angle identities. Now, when you change the equation and you can make it all in one trig function, that's the easiest. Sometimes that doesn't happen. Sometimes no matter what you change, you still have two trig functions in the equation. In that case, we're going to want to try to see if we can factor, maybe we can factor out a common factor so that we can solve it. Another strategy, if you can't see what to do with any of them, you can use a strategy similar to what we use in proofs, is change things to sine and cos, and then eliminate any fractions and see where you can go from there. So here is our first question to try. We're going to solve for theta between 0 and 2 pi, and we have cotangent of theta equals 2 cos theta. So initially looking at it, yes, we have two different trig functions here. That means this is going to be hard to solve for. So we try to think, well, can I change cos to cotangent, or can I change cotangent to cos? Do we have something that would change one of these to get things all in one trig function? And that doesn't work in this case. So since we can't change it all to one trig function, we might start by saying, well, let's change things to sine and cos. I know I can change cotangent to cos theta over sine theta is equal to 2 cos theta. And at this time, we're using the last strategy listed at the top. We're changing things to sine and cos. And then it says eliminate any fractions. We have a fraction right now. We could get rid of that fraction by multiplying both sides by sine. So if I multiply both sides by sine, I get cos theta equals 2 cos theta sine theta. Now that we've changed things back to sine and cos, again we look, is there a way to change things so that we're only dealing in one trig function? And the temptation right here is for students to change the sine to 1 minus cos. We have to be careful with that. Sine squared is equal to 1 minus cos squared, but that does not mean that sine is equal to 1 minus cos. So you can't just take the square root of each individual thing. Mathematically, that doesn't work. If you want to check, you know that 3 squared plus 4 squared equals 5 squared, right? A squared plus b squared equals c squared. That's a common one. If you take the square root of each number, is 3 plus 4 equal to 5? No. I saw someone taking out their calculator just to check. Yeah, no, doesn't work. So we can't just change the sine theta to 1 minus cos theta. But you might be tempted to do that. Most people aren't tempted to say 3 plus 4 is 5. It's more tempting to say 1 minus cos is equal to sine. But for the same reason, they both don't work. So if you get to a situation where you can't change things, the key is to set one side equal to 0 and see if you can factor. So in this case, if I set this side equal to 0, I subtract the cos theta on both sides. There's a common factor of cos in both of those terms. So we can factor that common factor out, leaving us with 2 sine theta minus 1. And once you've factored it, where you have the multiplication, things get split up, and on either side, one side just has cos, the other side just has sine, so we can solve this. Here, cos theta could equal 0, and here, sine theta could equal half. Cos of theta equals 0. When can that happen? Pi over 2 and 3 pi over 2. Sine of theta equals half. When does that happen? Pi over 6 and quadrant 2, 5 pi over 6. Now that we've got our answers, we naturally solve things between 0 and 2 pi. I'm just going to check the question. Was the question between 0 and 2 pi? It was. So I always do a quick check of my domain at the end to make sure that it fits in the answers that I've gotten. In this case, I don't have to change any. Now I want to point out a couple of other things, because when I teach something to you and I show you the method of doing it, it makes sense and you nod your head. But when you get to a quiz or a test, sometimes you forget things. And then when you forget things, you try to figure things out. And in those moments when you're trying to figure things out, that's when we make mistakes that didn't happen in class. That's why I did that survey with plugging in the numbers. Because when you go to do it on your own, you're going to go with what your gut feels, and you might make a mistake. So I'm going to show you another common mistake that happens in this question. And it happens right here in this step. Okay? Because one of your strategies, your very first strategy, is write things with only one trig function. And if you're thinking about that, a lot of times people will go, hey, if I divide this side by cos and this side by cos, what's going to happen? My coses are going to go away, and I only have sine. So I have changed things to one trig function. And it appears like I'm not doing anything mathematically wrong. If you were to do that and cancel these out, you get 2 sine theta equals 1, and solving it, you will get these two answers. But you won't get these two answers. And the reason for that is, if we look at the blue at this point right here, can you see just visually that if cos is 0, it's going to work? Because this side's going to be 0, and that side's going to be 0. So the danger right here, because cos can be 0, the reason you're not allowed to divide both sides by cos is because you're dividing by possibly 0, and that's not allowed. So when you see something that says, maybe I should divide to cancel things out, that's where I want you to think that dividing is basically the same thing as factoring. So if you can factor instead, make one side equal to 0 and factor it out instead of dividing it out, then you're not going to miss these extra answers. Okay, some more notes. I'll give you some time to write them down, because now that we have double angle identities, in solving questions, you can get them mixed up. When is something a multi-revolution question, and when is something a double angle identity that I should substitute it out? So I've got the times that you would use multi-revolution, what has to happen in the equation, and the times where you'd use the double angle, and then we'll do an example with each. So you recognize if you should use the strategies of a multi-revolution question if that's the only trig function in the equation besides numbers. So here's our example, solve between 0 and 2 pi. Cos 2x minus root 3 over 2 equals 0. The only trig function we have is that cos function, and it happens to be a double angle inside of it. So if that's the case, then you'll solve it like a multi-revolution question. which means you'll get cos 2x by itself. So cos 2x would equal root 3 over 2. Since x is between 0 and 2 pi, 2x's would be between 0 and 4 pi. That's twice around the circle. Is cos ever root 3 over 2? What family is that? Pi over 6 family. What quadrants would you look in? 1 and 4. So we'd have pi over 6 in quadrant 1 and 11 pi over 6 in quadrant 4. That would be the first time around. In the second time around, you'd add 2 pi to this one. And of course, 2 pi is equal to 12 pi over 6. So you would get 13 pi over 6. And add 2 pi to 11 pi over 6 will give you 23 pi over 6. So there's our answers between 0 and 4 pi. And then solving for x, divide each of them by 2, which is multiplying by a half. You get pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. Now, if you have a double angle trig function and another trig function in the equation, then using your strategies for multi-revolution questions won't work. Then you're going to need to change the double angle trig function using its identity and then be able to solve it using our strategies from before. So here we're solving between 0 and 2 pi. We have sine 2x equals sine x. We have a double angle identity, but we also have another trig function in there. So we're going to start by changing it out. And then go through our strategies for solving. We still have 2 trig functions in this equation. So we think, can I change everything to a single trig function? Well, I can't change cos to 1 minus sine because it's not cos squared. So in this case, we can't do that. You might say to yourself, hey, I could divide both sides by sine, and then I get rid of the signs. But if you think I should divide by that instead, we're going to make one side equal to 0 and factor. So if I subtract the sine x on both sides and make it equal to 0, then I have a common factor of sine x and when we split it up right there, then they're separated. So sine x could equal 0. Cos x could equal a half. When is sine equal to 0? 0, pi, and 2 pi. When is cos equal to a half? Pi over 3 in quadrant 1, 5 pi over 3 in quadrant 4. Again, check our domain at the end. I'm going to be checking a couple of things. First of all, is it between 0 and 2 pi? It is. Are 0 and 2 pi included? Because you've had some questions out of your textbook where the 0 was included but the 2 pi wasn't. Or the 2 pi was included but the 0 wasn't. And that's going to be important in this case because we got those as answers. Do you see we have an answer of 0 and 2 pi? But when we look at our domain, in this case, both the 0 and the 2 pi were included, so we would leave all of our answers are fine. But again, it's always nice to check our domain at the end to make sure that it's fitting within what we're looking for. I'll give you your homework for these ones after we do example 4.